taking more than 133.15, hence it is safe in shear. So the section is safe in shear. Now let us go for the third step, step 3, which is check for movement of resistance. Check for movement of resistance. So as discussed earlier, I will show it once again. So check for movement of resistance. Now check for movement of resistance, we have to take it from page number 53 IS 800 2007 clause number 8.2.2. What we have, VU is less than equal to 0.6 VD. So however, we have already proved that the value of, we have already proved in the previous case that VU is less than 0.6 VD. So we are going to use that formula. So I will write here, we already know that VU is less than equal to 0.6 VD. So which case it is coming? So we know that VU point less than, so it is a case 1. So I will write here, it is for case 1. What is this case 1? If VU is less than equal to 0.6 VD. So for this, what should be taken? So the design bending strength MD shall be taken as MD is equal to beta B ZP Fy divided by gamma m naught, page number 53 IS 800 2000 clause number 8.2.1.2. So I will show it once again. So it is from here, when the factor design shear force does not exceed 0.6 VD, where VD is the design shear strength, then the design bending strength MD shall be taken as MD is equal to beta B ZP Fy divided by gamma m naught. So I'll write here, I'll write it here. So this is taken from clause 8.2.1.2, page 53 IS 800 2007. So the formula from the code book I will write. So the formula is design bending strength is nothing but MD beta B ZP Fy divided by gamma m naught. Now it is clearly given that where beta B is 1 for plastic and compact section, and here also we have MD shall be less than 1.2 ZE Fy divided by gamma naught in case of simply supported. Our case is simply supported, so it should be less than equal to 1.2 ZE Fy divided by gamma m naught. So it should be less than 1.2 ZE Fy divided by gamma m naught. Why we are taking this? Because this is for simply supported case. Simply supported case. Now what we want? We want the value of beta B. So section to be classified. So I'll write it as section classification. So what ratios we want? As discussed in the earlier, so section classification is done according to this. This is the dimension. We have to find out two ratio, B by TF and D by TW. So I will find out B by TF, this is for flange, and D by TW. we have already noted down. So this is the section which we have for IS-17. So these are the component. So I will make the use of this and I will calculate. So here B is what? Outstand of the flange. So it will be, so the value of B is 140, but it should be as per us this component is B if you happen to see. So what is this B? Nothing but this divided by 2. So this will be 140 divided by 2 divided by thickness of flange. So thickness of flange earlier noted is 14.2 mm. So this is working out to be 4.92. Similarly, D by TF. Now what is D? I will just calculate. So D is nothing but this portion. So can I write it as total is H minus 2 times of thickness of the flange, because this is total H, I want so much, so I have to deduct 2 thickness of flanges, top and bottom. So thickness of flange is nothing but 14.2. So I will write the formula as H minus 2TF divided by thickness of web. H is nothing but the depth of the section minus 2 times thickness, we already know 14.2 divided by TW. So this is working out to be 39.703. TW is 8.1. So let us see. So what is epsilon value? Epsilon value is nothing but 250 divided by Fy half. Fy we already know is 250 Newton per mm square. So this will be equal to 1. So epsilon value is 1. Now we will go back to page number 18, where we will get the classification of section. So this is the classification of section. So two ratios we have found for rolled section, outstand of the flange, B by TF, and neutral axis depth D by TW. D by TW, which I have prepared a table, you can refer for it, that is this table. So what is happening here? This is the table. So B by TF, what is our B by TF? 4.92. Epsilon is 1. So what is happening? This component is less than this component is 4.92 epsilon, because it is 1, which is less than, you can see here, less than 9.4 epsilon. That is here in classification of section. Similarly, D by TW ratio is 39.703 epsilon, which is less than 84 epsilon. So what is happening? 4.92 epsilon, which is less than 9.4 epsilon, and 39.703 epsilon, which is less than 84 epsilon. The section is nothing but plastic. So I will comment here, the section is plastic section. So we got the classification of section. Why we are doing so much? Because you can see here we have something component called as beta B, which is dependent on the type of the section. Now we have classified the section. So as per the section is classified as plastic, so I will go to the clause. So beta B 1 for plastic. So what is our section? Our section is plastic. So beta B will be 1 as the section is plastic. Next is what? ZP. Now what is this ZP? ZP is given here. So ZP is nothing but plastic section modulus of the cross section. So I'll write ZP plastic section modulus. So from where to get this? We will get in the codebook itself in the table number 40. Table number 40. So I will just take it to you. So page number 138. So this is page number 138 and this table is about plastic properties of the beam. So our section is ISMB 350 at 52.4. So you can see the plastic section is C against this here. So I'll just keep it in this fashion. So you can see against ISMB 350, go on checking here. So this is 891.03. This is the value of plastic modulus. So note down it from here. So I will write the value of which is 889.57. This is in terms of centimeter cube. So what I will write 889.57 into 10 raised to 3 into mm cube. Now I will also write this we have taken from where? So we have taken from table 40 page 138. Remember, so this we have taken from table 40. So you can see in the formula what all are required. ZP is there, beta B is there, Fy we already know, gamma m naught. So we can substitute and get the answer for it. So the MD is nothing but this formula, beta B ZP Fy. So beta B value is 1 into ZP is this 889.57 into 10 raised to 3. Then we have Fy is 250 divided by gamma m naught is 1.10. So let us compute this. So 1 into 889.57 into 10 raised to 3 into 250 divided by 1.1. So we are getting this as 202.175 into 10 raised to 6, which is Newton mm. I will convert it into kilonewton meter. So this is 202.175 kilonewton meter. So this is MD. This is MD. Okay. So we have also computed the value of maximum moment. So mu is what? 166.518 kilonewton meter from the early case. So what is happening? MD, which is 202.175 kilonewton meter, which is greater, correct, which is greater than the calculated maximum bending moment, which is 166.518, which is greater than mu, which is 166.518 kilonewton meter. Hence it is safe. Hence it is safe. Hence it is safe. So we have done today 3 steps. One is, I will just make a note of it. So we have noted on the properties, calculated the load, calculated bending moment, calculated shear force. We did check for shear for the condition, and we checked that Vu is less than 0.6 Vd. Then we started with moment of resistance. We already checked for shear, so we got to know that this is case 1. So for this we noted down the formula. We should know the value of beta b. To get the value of beta b, we should know the classification of section. So how do we classify? By this ratio, b by tf and d by tw. Make a note, this b is the outstand of the flange, which is half of the width, and d is nothing but the web depth. So web depth, I will get total depth minus 2 times thickness of flange. So we will get the ratios. So we got 4.92 epsilon and 39.73 epsilon. We just went into the plastic section table and we got to know that this is a plastic section. Once we got to know that this section is plastic, we will get the value of beta b, which is 1. Next wanted is zp. So we calculated zp from the table number page 138. We got this. We calculated the value of md, which was 202.1705, which is greater than the maximum bending moment, hence it is safe. So students, for today we will stop here. We have done 3 component load calculation, check for shear, check for moment of resistance. So for today we will close the session. In the next lecture we will continue with the other checks, that is check for deflection, check for web crippling, check for web buckling. Till then, stay home, be safe. Thank you one and all.